everybody. So today we are going to continue with higher order derivatives and word problems, because what is more fun than doing derivatives and word problems together in the same day? So what we're going to talk about is first is taking the second derivative. So when you take the first derivative, we call that dy dx. When we take the second derivative, d dx means we're taking the derivative of dy dx, and the notation here is d squared y over dx squared. I know it looks really weird. You would feel like there should be parentheses. Usually I just call it y double prime, or the second derivative, but this is the notation for the second derivative. So essentially you just keep taking the derivative of the derivative. So for number one, find the first four derivatives of this. So y prime, or dy dx, we'll just use power rule. Bring your 3 forward, drop your exponent down by 1, bring your 2 forward, it's going to multiply to the 5, so minus 10x, and then the derivative of 2 is just 0. Okay, so now we'll do that again for the second derivative. Just use power rule again. Bring your 2 forward, 6x, derivative of negative 10x is just negative 10. Then we do it again. Derivative of 6x is just 6. Derivative of negative 10 is 0. And then our last one. The derivative of 6 is just 0. Ta-da! I know I say that a lot. I try to make it very exciting for you to take these notes. Alright, now this one gets a little trickier. We're going to find dE dB, so that's the derivative of E with respect to B, where R, A, and C are all constants. Alright, so B here is the only variable. R, A, and C are just numbers. So when we're taking the derivative, or E prime, the derivative of this whole thing is just 0, because those are just numbers. Plus, B is the variable. So this would be like the same as, I don't know, like a 2 over 5x. C and A are just numbers. So the derivative of 2/5 x is just 2/5. So the derivative of CB over A is just C over A. Alright, so be careful. Make sure you know which ones are variables and which ones are numbers, and then that tells you how you're taking the derivative. Okay, so now let's do this again, but with a product. Let's try this 2 different ways. We can either FOIL and then take the derivative, or do product rule. dr dm is what we're finding. That means m is the variable. Everything else is a constant. Okay, let's use our FOIL method first. So FOIL, right now we're just finding r. We're not taking the derivative yet. So that would be m cubed over 3 plus am squared over c minus bm over 3 minus ab over c. And I'm just going to highlight, this is my variable, this is my variable, this is my variable. Alright, so now I can go ahead and I can use power rule and find r prime. So I have m cubed, that's the variable, that's become 3m squared, it's still over 3. So these will cancel, and I'm just going to get m squared plus, basically taking the derivative of the m squared, bring your 2 forward, 2am over c. Okay, that just stays the same. Okay, minus the derivative of bm over 3. So think about your 1 just coming forward, that's just minus b over 3. And this does not have any variables, so when we take the derivative, it's just 0. So there you go, option 1. Option 2, we're going to use product rule. Which is u prime v plus uv prime. So u prime is just going to be 2m, oops, I should put my notation, r prime. So this is u and v. So u prime is just 2m times v. So v just stays the same. Plus u, so u stays the same, times v prime. V prime, your only variable is m here. So v prime just becomes a 1/3. And now I can distribute 2m squared over 3 plus 2am over c. I'm putting the m second because that's my variable. That just helps me a little bit. Plus 1/3 m squared minus b over 3. And then you can see that if you combine your like terms, 2m squared over 3 plus 1/3 m squared, that gives you 3m squared over 3, which is just m squared. And that should be the exact same thing as what we had before. Okay, so obviously you don't have to do this 2 different ways. I'm just showing you that there are 2 different ways to do it. You can do whatever you'd like. Alright, flip to the back. Let's try something else. This time I give you u of 1 is 3, u prime of 1 is -2, v of 1 is 4, and v prime of 1 is 1. So notice these are the slopes because it has the derivative. So the derivative is the slope. So we're going to find the derivative of all these different situations. And it says that x equals 1 for each of these because our x value is 1 for all of them. So d dx of uv, that's going to be product rule. U times v, to take the derivative, we do need to do product rule there. Okay, so I have u prime v plus uv prime. And now I'm just going to go ahead and I'm going to plug in these values. Okay, so u prime is at 1 is -2 times v at 1 is just 4, plus u at 1 is 3 times v prime is 1. So that's -8 plus 3, which is -5. Okay, and that's my answer. The next one we can see we're going to have to do quotient rule here because we're dividing. So quotient rule, remember, is very similar to product rule. U prime v minus uv prime all over v squared. Okay, so now we'll plug our numbers in. U prime, -2, times v, 4, minus u, that's 3, times v prime is 1, all over v squared. That's -8 minus 3 over 16, which is -11/16. Okay. All right, so 2uv, when we take the derivative of that, you have an option. You can take the derivative of uv and then double it. That'll probably be faster. Or you could treat it as product rule and have like this be your u and then the v be your v. So it would be like 2u prime v plus 2u v prime. Okay. What is probably faster is just to take uv, which we already did up here, and we got -5, and then multiply it by 2. So your answer should be -10. But let me show you this way. You can skip it if you want. Oh, I gotta go up so I can see what all these are. So 2u prime is -2 times v is 4 plus 2 times u times v prime is 1. So if you notice, that's -4 times 4, -16 plus 2 times 3 is 6, which also gives you that negative 10. Tangent and normal lines. You thought you were done with them, but you're not. Tangent line of v of x at x equals 1. Well, v of x, what we need is a slope and a point. At x equals 1, the point of v of x is 1, 4. And the slope is what v prime would be, which is just 1. So now we'll just write our tangent line. And that's it. The second one, we're doing normal line of u of x. So just notice we are over here now. The point for u of x would be 1, 3. The slope is originally negative 2. Right? Our slope is our derivative, but we want normal. Remember, derivative is slope of the tangent, so the normal slope would be 1/2. And then you can just write your equation. Okay, and there's that. All right, one more. Here's your word problem that I know you were excited about. An orange farmer has 200 trees yielding an average of 13 bushels of oranges per tree. She is expanding her farm at a rate of 15 trees per year, while improved husbandry, which apparently is a word meaning farming methods, is improving her average annual yield by 1.2 bushels per tree. What is the current instantaneous rate of increase of her total annual production of oranges? Okay, well first I feel like we need to draw a picture to represent the situation. This is my orange tree. It's beautiful, I know. Okay, so what are we trying to find? Rate of increase of her total annual production of oranges. Well, rate of increase, that's talking about a slope, which means we need to find the derivative. Annual production is what we're going to find derivative of. So, how do you find the production? Well, the production is just going to be how many trees you have times how many bushels you're getting per tree, right? So like if you have 200 trees and you're getting 13 bushels per tree, that would be what your production is, okay? But we don't want her current production, we want her rate of increase. So how is her production increasing? At what rate? So we can't just multiply t times b. We need to take the derivative. And to take the derivative, we will have to use product rule. So that's going to be t prime b plus tb prime. Okay, where again t is number of trees and b is bushels per tree. All right, so let's see if we can identify what each of these numbers mean. T prime would be the derivative of the number of trees, or in other words, how many trees are changing per year. So that would be this 15. She's expanding her farm at a rate of 15 trees per year. B is the current number of bushels per year, so that would be my 13. T is my current number of trees, that would be 200. And B prime is the rate at which the bushels per tree is changing. And because of this improved husbandry, her average annual yield is increasing by 1.2 bushels per tree. So that's the rate or the slope. Okay, and then we'll just type this into our calculator. And we get 435. Okay, so her current rate of increase is 435 bushels of oranges per year for right now, which I think is pretty good. Okay, there you go. There's some day 8, and I hope you enjoyed more derivatives. Better than difference quotient, right? Have a great day.